Now let's draw a line from the center of the semicircle to meet point C on the circumference of the semicircle, and also another line from the center O to meet point D at the circumference of the circle. Just like this. So as you realize, OC, so this is the center O, so OC is the radius, also OD is the radius, whereby also OB is the radius. So this line is equals to this line, is also equals to this line, which is equals to the radius. Now in triangle OBD, since OB is equals to OD, that implies that OBD is an isosceles triangle, and therefore if this angle here is 57 degrees, that implies that this angle will also be 57 degrees. And remember, interior angles of a triangle add up to 180 degrees. Therefore, this angle DOB will be equals to 180 degrees minus 57 degrees minus 57 degrees, which is equals to 180 degrees minus 114 degrees, which is equals to 66 degrees. So this is 66 degrees. Now, in triangle BOD and triangle COD, this triangle here and this triangle here, BO is equals to CO. So this line is equals to this line, which are both the radius. Also, OD is equals to OD, which they share. And BD is equals to DC. So this implies that triangle BOD is congruent to triangle COD. Therefore, implying that angle BOD is equals to angle COD. So this angle here is also 66 degrees. Also, so yeah, it's 66 degrees. Now we know that in any circle, in any given circle where we have a chord AB, and this is the center O, and we have this angle that is subtended at the circumference from the chord. If this angle is theta, then this angle here at the circumference will be theta divided by 2. So that if in reference to that, in our diagram here, so given the chord B, if this is the chord BC, now this angle from the center is, so angle BOC is 66 degrees plus 66 degrees, which is equals to 132 degrees. So this is 132 degrees. Now from the same chord CB, there is an angle at the subtended at the circumference. So from this chord, so from the chord B up to this point of circumference A, so this implies that angle X from this, it will be equals to this angle, which is 132 divided by 2, which will be equals to 66 degrees. And therefore, X is equals to 66 degrees. Let's look at another way in which you could have found the value of X. So let's start by joining point A to D. Just like this, we know that in any circle, if this is the diameter and any angle that is subtended from the circumference, from the diameter to the circumference of the circle is 90 degrees. Even if we had it like this angle would be 90 degrees. That implies that since this is the diameter of this semicircle and the angle is being subtended at the circumference from the diameter, that implies that this angle here is 90 degrees. Now in this triangle ABD, angle BAD, this angle here, is equals to 180 degrees minus 90 degrees minus 57 degrees, which is equals to 180 minus 90 is 90 degrees minus 57 degrees, which is equals to 33 degrees. Therefore, this angle is 33 degrees. Now, we know that in any circle, if you have a chord, say A, B, and you have another chord, CD, and then we have this chord to this, and also this chord to this. Now, if this chord is equals this is equals to this, if this angle here is theta, that implies that this angle will also be theta. If this AB, chord AB is equals to chord CD, then this angle will be equals to this angle. Now, since in our figure BD is equals to CD, that implies that angle BAD is equals to angle CAD. So this angle is equals to this angle. So if this is 33 degrees, this will also be 33 degrees. And therefore, X will be equals to this angle plus this angle, which is 33 degrees plus 33 degrees. And therefore, X is equals to 66 degrees. So that's how you solve. Thank you so much for watching.